Okay, so this is a quick review of how to do a t-test, and then the rest of it will be about the project that covers a population proportion test, which is that Chapter 8A lab, the one that you have to do. And then I'll talk about the 8B lab in a separate video for those of you that want to go ahead and do the extra credit project. So this is the t-test. This was the last thing that we were doing in the homework. And this is a problem from the back of the textbook. Researchers collected a simple random sample. They had 81 college students, and they looked at how long it took them to finish their bachelor's degree. So we got 81 students. They found a mean of 4.8 years and a standard deviation of 2.2. We want to use a 0.05 significance to test the claim that the mean for all times college students is greater than the 4.5. So if we're talking about my claim, we're saying that it's greater than a 4.5. That's my claim. So the opposite of that is less than or equal to, and we usually just go ahead and write the equal to. That is my H naught, right? That's my null. This is my H sub 1. That'll be my alternative. So what we're looking at, not a very well drawn, but we have our bell curve, and we are looking at a right tail test. I got a 0.95 over here, and the tail is going to eat up, just that one tail is going to eat up that whole section. So if I wanted to know that critical value to compare to that test stat that we're going to get from the calculator in a second, I would say, all right, I have 81, so that means DF is 80. And I got a one tail, so we need to go to my stat card, scroll, 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 down to the t values. And I got an area in one tail, so this guy right here, of a 0.5, and then I'm going to travel all the way down to the 80, which is this number right there. And so my cutoff is a 1.664, and so I will pull that back up, and I will write 1.664, so that if it is a number, my test that's higher than that, then we're going to be in the red zone. Well, we're not going to do a test stat by hand. There's no need, so we'll pull up the calculator. We'll go into stat, test, t-test. I have the stat, so I'll type that in. In my null, I have a 4.5. My x bar was 4.8, I believe. Yep. Standard deviation of a 2.2. N is 81, and this needs to match what is in my alternate, which is that. And I will hit calculate, and I get a t-value of a 1.23 basically. So I have something like that over here of a 1.23. So I am definitely in this green zone, which means I'm going to fail to reject. That means I keep the null, which is bad news for us, because I wanted to say that it took longer than 4.5 years. I would say it probably takes about 4.5 years in real life. It's pretty accurate. The other thing that you could have done, that if you didn't want to look up this critical t, is compared your p-values. You see you got this capital P here of a 0.8883. Well, 0.8883 is not less than the 0.05. And if the p is low, the null goes. Well, this is not low, so it does not go, and we keep it. And so now we're going to state the conclusion, which basically that there is sufficient evidence to warrant the rejection of my claim. But you know, sometimes they like to mix it up, so we'll go into here and we'll pull up that sheet that had my conclusions. Did the claim contain the equality? No. Did we reject it? No. There's not sufficient sample evidence to support my claim. So that one would be something that is a normal conclusion statement. On your final, you will have to pick the correct conclusion statement. So even though you can say it a couple of different ways, they're asking specifically on the final for one of these four. On the test and on the project, as long as you get the basic idea right, I'm fine with you not having it exactly worded the way that this is here, as long as you're saying, yeah, I supported my claim, I didn't support my claim. So now let's talk about 8A. 8A is about stents, and we talked a little bit about a class the other day. A stent, if you don't know, is kind of like a oh goodness, what would it be? It's almost like you put it into your artery and you pop it open to keep it from the walls from falling down. When your artery gets clogged, like this lovely little guy right here, it gets squeezed, 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 and so the blood flow can't go into the heart, and that's how you get a heart attack. And so you got a couple of different things you can do. You can put this stent in, and they put in this balloon catheter, right? And they pop it out, and then they like deflate the balloon, and they pull it out, and you have the stent in. You can go in and clean it out, or you can go ahead and just take medicine to take care of it. It really depends on how far along you are. If they're rushing you to surgery, if you're severely clogged, if it's just minor, they may just go ahead and put you on meds. I believe they check it by doing almost like, I don't know if remember like a GI series, you drink this disgusting chalky stuff and then they can follow it through. I think it's the same way there. Now the hardest part about this was really that it wasn't very clear about where your claim was and where your information was. So this is put in a stent versus a surgery of going in and cleaning it out. They want to test the claim that the stent was effective. Their claim is 38.6% of patients treated suffered a heart attack, a stroke, or died within 3 years of the surgery. So they took a sample, 41 of the 143 patients had that happen to them. Test this claim right here, which is not very clear that this is the case. So my P is that it's a 0.386, which means that this is not equal to 0.386. And you can type in the not equal to, that's fine. You can also go up to insert symbol and use the not equal to. Either way is fine. That doesn't bother me. What type of test is this? This is a two-tailed test. And you have some critical values. Since my alpha is a 0.05, I'm going to have criticals at a negative 1.96 and a positive 1.96. And I'm also going to go ahead now and run, I spelled critical wrong. Oh, it's because it's criticals. Run my test to get my test statistic. This is a population proportion, so this is back to 8.2, I believe. So stat test 1 prop z test. 0.386 is my claim. I had 41 of the 143 unfortunately have a heart attack or stroke or pass away. Not equal to my null, and I calculate, and I get a z of a negative 2.44. So I have a z of a negative 2.44, which gives me this p-value. Now it says by hand. There's a couple of different ways that you could do it by hand or in the calculator. I would expect that most people would do what I just did and put it into your calculator. That's totally fine. If you want to take all of this information and snip it, and then go ahead and put it in somewhere, that's totally fine. The other calculator, you can do that as well. You can also do a screenshot, and you've got a lot of different ways that you can pull it up. It really, any way is fine. This is the important part. So what's your conclusion? My p-value is a 0.014. And this certainly lands in the red zone. So I am going to reject the null. Which, whether that's good or bad, we don't know if it's more than 40% or less than 40%. But there is sufficient sample evidence to warrant the rejection of the claim. Because this was my claim right up here. And that's how you're going to kind of go through those. Now these I think were a little tricky. This one is a less than for this guy right here. That's a less than in here. We want to say that reduce, so that's a less than. And then this one also was a little sneaky. We want to say that the medicine was actually better, and so that this is going to be a greater than. We're saying the medicine is actually doing a better job than the stents. At one point when this was written, all of this was true. I'm sure it may have changed, and I'm sure it depends on your situation. So you have to walk through those other two just like you did this one. And that's the one that is required, and hopefully you can get that in within the next week or so. This is for the T-test and the 8A, and the next one that I will be making any moment is for the 8B lab.